Hello, my name is Denis Silin, and I'm the CEO and founder of Exodus Orbitals. Today I want to introduce my vision how we can settle 1 million people on Mars in 25 years. But first of all, let me give you some background about myself and my past experience. My first brush with space exploration came in 2011, where I was a speaker at 100-year Starship Symposium organized by NASA and DARPA, where I presented my thoughts on interplanetary and interstellar colonization. I was just an undergrad student at the time, but nevertheless, that was the seed of an idea I'm going to elaborate on today. After that, I was working in a variety of jobs at software industry, but then I decided to pursue my passion a bit more. And in 2016, I joined master's program in astronautics and space engineering and graduated in 2019. And this was also the year when I founded Exodus Orbitals. After a while, I worked in aerospace industry on a variety of projects and tried to push my company as well. And in 2019, I joined European Space Agency mission called OPSAT, which was about software-defined satellites. This mission was successfully launched in December 2019, and I worked as part of the onboard experimenters for a while. But my vision was always the big one. And today, I'm going to share this vision with all of you.
So I want to present our vision of Martian exploration. Our vision we named Prometheus Unbound. Just like an ancient hero who got unbound from his suffering, humanity will get unbound from the chains of Earth's gravity and expand beyond our planet. Now we have an idea how we can settle 1 million people on Mars by 2050, and today I want to give you more details how exactly. So this goal is difficult, and a lot of challenges that we already know about we have to face on Mars. It is thin atmosphere, radiation, impact of low gravity, technological challenges, logistics, bootstrapping entire industry sectors, and designing the closed loop ecosystem. And of course, one of the bigger one is what kind of society do you want to build on another planet? What kind of people do you want to draw? What culture to build? Plus all the unknown unknowns, which we don't know yet, but we'll have to face when we set our foot on another planet. So, how to approach this big challenge? We have a known method to solve big grand problems, and one good example in space industry is SpaceX scaling up from the small Falcon 1 to the big Starship. It took a lot of effort, but what's important, how they did it through repeatedly iterating, launching the rockets, scaling up, launching bigger rockets, learning from lessons to eliminate all the possible risks, and scaling up. Each stage took multiple attempts, but with every step, they moved it forward. Little by little, they went from the small, expandable rocket to the largest reusable launch system in the world. This is the lesson learned, which we want to use for our vision. But first of all, let's set some milestone. Of course, we cannot, teleport 1 million people to Mars tomorrow. There will be intermediate milestones and intermediate goals to reach. If we look at the state of the space exploration today, we have about 10 people in low Earth orbit. So the next obvious step is increase this number. I give you one example of having 100 people in low Earth orbit within the next 7 years by 2023. This is a good intermediate goal. The other thing, as much as we are scaling up the presence of humans in space, we need to scale down the price of doing so. So right now, the cost of space tourists going to International Space Station is roughly $20 million. If we want to increase the number of people, we have to find a way to drop the price. Drop it down 20 times to 1 million, and the goal of reaching 100 people in low Earth orbit will become easier. We also want to have another next intermediate goal. The 10,000 people on the moon would be an amazing thing to have in preparation for large-scale Martian colonization, as it allows us to scale a lot of technical solutions, allows us to build institutional knowledge, and allows us to have a pool of people that will have some spaceflight experience that will be large enough to support our next and final step. Same with the cost. 1 million can be lowered down a lot more if we are talking about thousands of people on the moon. This price can be set on 150K and be within limits for many people to have a vacation on the moon, or hire more people to support those to support the space tourism at much larger scale. Those people, both the tourists and the support staff, will actually form that institutional knowledge we need to go. And it doesn't need to happen instantly, another 7 to 8 years before reaching this goal. But what's important, we need to aggressively scale up and push as hard as possible for this kind of numbers. And by this time, by say 2050, large-scale effort to settle down people on Mars, thousands, 100,000s, will become affordable if we continue pushing in this direction. And by this time, the cost of one-way travel to Mars may become as low as $10,000, similar to the price of business class travel across Pacific or Atlantic. That itself would be a great goal to reach. Now, how we solve that ambitious roadmap and achieve those goals? The same thing as I mentioned before, we need to split our grand challenge into the smaller parts, set intermediate milestones at each destination. We don't need to go all the way from Earth to Martian surface in one take. We can use intermediate steps, such as low Earth orbit, lunar surface, to develop our technology, to develop our institutional knowledge, to train the people, to learn more about the challenges of interplanetary environments, and in the end, prepare a foundation, an infrastructure, and knowledge base to be ready for the final big step. Now, I want to talk a little bit how I imagine each iteration. They will be similar in structure for both, Earth orbit and surface, lunar orbit and surface, Martian orbit and surface. Why? Because we can reuse the solutions we developed on each step for the next one. So moon is not a distraction. It's an important training ground, important destination to develop and polish our technology, and because it's much closer to Earth, it will be much easier to support it. So orbital segment, it will be in orbit around Moon or Mars and will be used as logistics and support base, and also later as an industry base and agricultural facility, because orbital environment is a lot more similar in both Earth orbit, Moon orbit, and Martian orbit. The fraction of technologies and knowledge being reused will be good, will be significant. We can reuse the lunar orbital station in orbit around Mars with almost no or minimal changes. This allows us to be conservative in taking the risk. We don't need to go to another planet with unproven technology. The goal of each step is to develop just enough solution solutions so we can take them with confidence to another planet. Now, of course, we're not limited to just an orbit. We will have a surface segment as well, resource mining and some manufacturing. Other facilities can be deployed on the surface. Probably multiple surface bases will be built on Moon or Mars. What's important? The logistics shoulder between the orbit and surface will be short. If we're supporting a surface base on Mars, our next support base is not Earth. Our next support base is Martian orbit. If anything happens on the surface, help will be only hours away, not months away. If any surface base will fail, they can always evacuate back to orbit and start again at a different destination. So, of course, that raises some question, how exactly are we going to develop our orbital segment? And that's the best part. We don't need to start from absolute zero. We already have International Space Station as the first point of reference. Of course, it is limited in what it can do, limited in capabilities, limited in size, limited in number of people, and it's quite expensive to support and operate. However, it is a starting point, and we can take it from here. We don't need to develop our orbital segment from absolute zero. We already have quite a big body of knowledge in terms of building orbital space stations. So here is our proposed first step. Build a much larger orbital station in low Earth orbit with the following capabilities: artificial gravity at Moon or Mars level, extended manufacturing and extended agricultural facilities with 3 times the number of people at least it can support. Of course, it's going to be a large space station, and we will need a heavy lift launch vehicle available, but that's going to be available literally in the next year or two. And it's not going to be small in size, more than 3 times the mass of International Space Station, but the big size allows us a lot more capabilities to fit a lot more people, to develop artificial gravity. And why it is important? Because we don't know how gravity at Moon and Mars level will impact the health of colonists, especially people living there for years, and the second generation of interplanetary settlers, the people who will be born. If we want to go there, we want to know all the answers before the first man steps his foot on Mars, the Moon. The less unknown risks we have to face, the bigger will be the probability of success. And of course, as we're developing our orbital segment, a lot of the things we will develop, like orbital assembly or in-orbit manufacturing and agriculture, will be directly applicable in other destinations in orbit around planetary bodies. Some business model. Example of the whatever steps, whatever efforts we're going to make, they cannot be a financial black hole. So we developed a space hotel business model where enough revenue can be generated from the operation of this space station as a space hotel with paying customers with $1 million price per 7-day trip, so it can support itself. So it's not just a research and development base, it is a commercial project that can return on investment. And we set a very conservative price point for the construction at $1,000 per kilogram for the 10 months of per year utilization, and 17 months of construction and another 6 months of commissioning. So we have some realistic assumptions, and it's not just an optimistic sky, pie in the sky kind of dream, it's definitely possible to build and operate space station like that. And if more than one is built, we can easily reach our goal of 100 people in low Earth orbit. Logistics. So as we can get more stuff done in orbit around LEO, we can do a better job of recycling of the food, oxygen, and water, and get more stuff manufactured in orbit, which is going to be important as we're going to move farther away from Earth. We need our orbital base to become more and more self-sustainable. The next step, we can take the same basic design and launch it and move it to the moon orbit. The only change we want to implement is deep space radiation shielding and support for 1G artificial gravity for the worst case scenario, in case of partial gravity is not compatible with long-term survival and thriving of a population on the surface. They have a fallback option, which is immediately available to them in orbit around planetary body. They can stay and live in orbit and go to the surface as frequently as they want, while not compromising on their quality of life. And of course, this scenario assumes that most of the population will live in orbit, and the surface segment will support primary mining and certain manufacturing parts like regolith mining and water ice mining, and some tourism-oriented activities. On the moon, I would say that would be most likely scenario, but what's important, a big orbital segment, big fraction of the population living on the moon will give us the opportunity to build a culture of spacefaring people, skills and experience, which is hard to replicate or impossible to replicate in Earth. And it also will be our first deep space destination, which will push the people and the technical systems to be more self-sufficient and the more robust in the face of the space, in the face of the challenges in space. But I'll come back to that later. In a similar manner, our moon base doesn't need to be a sink, a cost sink. If we look at the existing tourism industry, people craving new destinations. People want to see new places. Remember, if we want to drop the price of our ticket to 150,000, we can access a much larger pool of potential people that are willing to pay. So we can take inspiration from the mountaineering in Himalaya. There's plenty of people going there every year, but it's the same in basically mountains. Now we can offer them a new opportunity. Go and climb lunar mountains. Plenty of other landmarks, such as Apollo landing sites and other spacecraft there. All that is required in infrastructure to support us. And our moon base, both on the surface and in orbit, can become such a tourist town, a city in space for people who want to explore moon. And if you look at the current efforts by NASA, we already have a seed of that, with the Lunar Gateway being our first take at the orbital segment around moon. And the plans for Artemis program involve lunar expedition being supported from orbit. Now we just want to scale it and don't have just 3 people on the moon, have thousands of people on the moon, similar to how many thousands are summiting Mount Everest. There is enough revenue from that on Earth, and there should be enough revenue to support the moon base in a similar manner with the flow of the space tourists. Now, because we will have a lot more infrastructure, we have more people, our lunar economy can become a lot more self-sufficient. We have relatively shallow gravity well, and things we mine from surface will be immediately available either on the surface or the processing facilities in orbit. So the goal is to develop our orbital segment to be as much self-sufficient as possible, with water and food and large fraction of the hardware to be able to be manufactured in orbit. Remember, we are taking this solution to the next step. So we can develop industry that can survive on the resources that can be mined from the planetary body nearby, Moon, for example, in this case, and also develop and build valuable goods and experience that can be exported back to Earth. So this lunar economy have some means to not just be self-supporting, but also will be profitable. And in this way, will draw more money, more capital, more resources as the growth opportunities will appear. Remember that everything we do in every step has the expectation of being used for the next one. So we are taking our lessons learned, our technologies developed, our orbital and surface solutions to the Mars. And as we learned over the past years, if we need to keep the momentum going, every next step should be larger than the previous one. So we're aiming for 1 million people on Mars, and there should be our orbital segment will be much larger both in scale and in the number of space stations around Mars. More people allows us strength in numbers. With thousands, we can build a self-supporting city. With millions, we can build a self-supporting nation. Again, the structure will be similar. Most of the population will reside in orbit, but there will be multiple surface facilities, primary in mining industry, and some kind of course, manufacturing and chemical industry. That depends on the proximity to the surface. But what orbital segment around orbit in Mars allows us two unique opportunities. The first one is orbital farming in orbit around Mars. It's actually going to be easier than on the surface because of the lack of solar dust storms and atmosphere effects. We will have more solar radiation available for us in orbit around Mars. So it makes more sense to focus our efforts in agriculture and farming in orbit, while delivering food to Martian surface can be done relatively easy. Just drop it through the same way that our Martian probes are being landed on Mars. You don't need to expend energy on that. And another opportunity, which would be silly to ignore, is asteroid mining technology. Mars has two small satellites, Phobos and Deimos, and they are pretty much like asteroids. Now we are in orbit around Mars. Why not use them? The delta V cost to them will be negligible from the Martian orbit, and the technologies used to develop asteroid mining solution, we can reuse our steps beyond Mars into asteroid belt, which allow us to expand, not just make our civilization multiplanetary, but keep the frontier of our civilization expanding. We don't need to stop at Mars once we master all the technologies we need for orbital habitat support, orbital industry sectors, orbital asteroid mining. You can essentially treat everybody in the solar system as just a resource base and keep most of the people in the orbital segments, developing them, developing them can take over the course for the next 25 years as we try to settle Mars. Again, money is important. Mars should not be another black hole in terms of resources. So you can imagine repeating, our historical experience and take lessons from the New World colonization. Plenty of land and resources, but low on labor. So you need to import labor. You need to make it also affordable for both the people who will come there and also make it financially attractive for the people who want to invest there. So we can split our total population into tenants and shareholders. And the tenant ticket will be only 10,000, affordable literally to millions of people worldwide, with the intention that the people will develop all the facilities for the shareholders, and shareholders are the ones who will be investing into Martian factories, habitats, agriculture, and of course the ticket will be much higher for them, but we don't need a lot of them. So say 10,000 shareholders, so stake owners, and 1 million of tenants will provide us with roughly equal amount of capital. At 20 billion total cash, we can borrow more money at favorable terms, and with that will be enough money, we'll have enough capital to build the foundations of our space colony. And of course, as we are not just building, technology, we are building a new nation of our planet. There's no reason why this nation cannot be a financially successful state, and we'll have things to export that are valuable on Earth, and this will allow the positive trade balance. Again, attracting more people, more capital, and more resources to make it grow and expand. Logistics will be similar to the lunar iteration, but now as we have more facilities, more people, we can push for more advanced manufacturing capabilities. We can push for manufacturing at scale with only limited amount of equipment required from Earth. That will allow Martian economy to develop their own indigenous solutions that might be valuable to be exported to Earth. I don't know what they will be at this point, but there will be definitely something that is only possible to build on Mars, either due technologies being developed or more open legal requirements, restrictions that can be valuable on Earth. And of course, people who experienced life in another planet, in another world, very different from the life on Earth, can become, valuable addition to the terrestrial culture, self-sufficient and, knowing how to innovate. They may benefit their own home countries if they choose to return. So it's not going to be a one-way flow of people from Earth to Mars. There will be a considerable backflow from Mars to Earth, and we never know what those people will be capable of once they have experienced life on another planet. Now, there is one more, important part which right now is mostly not well defined. What kind of culture, governance, what kind of people will be going there, and what are they going to build? Of course, we want to have the people on Mars and Moon to build the best possible version of culture and governance we have on Earth. And of course, those things do not appear by themselves. We have to make an effort to make them happen. And of course, we can use the same approach. Just like with technology, we iterate and scale. From a space hotel, culture in low Earth orbit, to city in space on the Moon, and nation in space on Mars. In low Earth orbit, I think it's pretty obvious where we can take our example, use best corporate culture from the terrestrial hospitality industry to build the space hotel. It is mostly safe environment, but accidents can happen. So crew need to attend to the needs of passengers, but also will take command in case of emergencies. And all the passengers, all the space tourists will be trained in the basics of spaceflight operations. That will allow them to become more familiar with space environment, and maybe we'll develop the seed of the spacefaring culture we will need for our next steps. Lunar orbit and surface are more distant destinations, so it places some more requirements on the discipline and skills of both the crew and the passengers. Think of, again, mountaineering in Himalaya. Both the crew, the guides, the Sherpa, and the people who want to summit Mount Everest need to have very good training and skills to do it successfully. Therefore, the environment itself will push the people to be better to each other, to be better trained, will weed out overly selfish people and unprepared, and in this way will help us grow the culture we need to take beyond our planet. Now, Mars is another step in this direction. It's a totally separate planet with months of travel away from Earth. And what is important is to develop an independent, almost a nation-like culture from the day one. What kind of people will be going there? Both people who have a lot of opportunities, wealth and power, who want to expand it, and also people from the marginalized, underrepresented communities that want to have a place for fresh start. We cannot ignore the geopolitical arguments, and we can assume major powers would be interested in expanding their domain there. So it is important to make the best out of all of it. Don't try to build a forced utopia, but what we can use is our historical experience. Use the best examples of institutions and cultural patterns that are persistent on Earth and take them to Mars. Think of the Mars as the opportunity to build the next iteration of the human civilization that will be better than the past ones. This is why it is important to have a fresh start. Cannot build a new state on Earth. It's already divided between the existing powers. But you can do it beyond our planet. So that answers the question why. Why do we need to go to Mars if we can, go to Antarctica, or it's mostly empty, or the deserts of Africa? The whole point of building an interplanetary civilization and making life multiplanetary is to build a better version of ourselves, of our civilization, of our culture, of the people. And Mars is sufficiently distant from Earth to allow fully independent growth and development. This is why it is a unique opportunity, and it goes beyond just building a colony on another planet. It's an opportunity to build a much better world out there. This will draw the people to come there, and will also inspire people on Earth to see that if it is possible to build a better civilization of planet, maybe it's going to be possible to improve the existing one on Earth. This is another cultural aspect which I want to highlight. Now, as I mentioned before, we are not limited to just Moon, Mars, and Earth. There are more than 1 million of smaller planetary bodies in solar system. Each of them can be colonized in a similar manner. An orbital segment with sufficient quality of life to support Earth-like conditions, radiation shielding, artificial gravity, closed-loop life support system, and self-sufficient manufacturing facility around every asteroid in solar system, planetary satellite, minor planets. And what is good, we can slowly expand, taking another step expanding further, astronomical unit by astronomical unit, as long as we want it to be. There is no upper bound to expansion. There is no limit to how far humans can expand into the solar system using this approach, and without using any exotic technology, just existing propulsion and other technologies. And you never know how far we can expand, how far we can reach. We have the entire universe open to us. And I think we should take the chance and go and bring our human spirit, bring the best into the boundless ocean of stars. Now, I'm not doing this just by myself. We have a team behind the vision and the team behind our company, Exodus Orbitals. So I'll invite you, I'm inviting you to join and inviting you to participate in a various manner. We have the social media presence, we have our own Discord server, and if you're interested in taking us seriously, we're also open for the investment opportunities.